It's very good morning to everyone. So today I'll be talking about there is an important module called as a Numpy. This Numpy is, comes under data science related module, so it's very important and there will be numerous situations we apply the Numpy module. Firstly, we must understand Numpy is very closely look like a list. Let me tell you something else about. We use import Numpy because Numpy is a built-in module. Okay, to do numerical operations. And Numpy is basically homogeneous rather than heterogeneous. See, there will be the list and there will be a Numpy are the two important models actually. So these are the collections we can say, right? So if you look at list data structure is heterogeneous, which means that the list will be allowed to be stored integers, float, strings, all this. But whereas the Numpy, Numpy will allow you to be stored the data in a homogeneous manner. Clear? Yeah. So Numpy is used to perform basic operations such as arithmetic operations. And apart from this, we do use linear algebraic functions. Linear algebraic functions. We use matrix operations. See, obviously, whenever you do the matrix operations, absolutely it will be image processing, video processing, everything. Absolutely, whenever we talk about matrix and linear algebra, we talk them as a data. But image and video processing is completely, it's an object detection concept. Computer vision, we can say. So absolutely, computer vision. All these will be the applications of the Numpy. Okay. Let us understand what we going to talk about in entire the Numpy module. It takes little few days. Please, from now onwards, the more practice is required, the more understanding is required. If you have any queries, please ask me without, because we are learning now what exactly AIML is. So far we have learned Python. That all are going to be useful for you, but here there is a specific purpose why we are learning Numpy package. Okay, so we learn about Numpy, such as basic operations of Numpy and how to create and print Numpy array and analyze and perform operations about Numpy. and utilize shape and shape manipulation and the copying methods. And demonstrate demo about how to execute linear algebraic functions and matrix functions. And obviously, we can build basic operations, basic programs using Python. Clear? So we will go with, what exactly, the quick difference between list and NumPy. What is the drawback of a list? Let me give you. Okay, because to overcome the drawbacks of the list, we are going to use the NumPy package. Okay, let us understand. Let us understand. So this file is available for you. You need not to type all this, just you practice. Whatever the hands-on I would give you, that you type. So whatever I'm writing, you need not to write it because this file is accessible for you. I'm just writing this everything in the where I hope you are privileged EIML July 2025 batch, where there will be NumPy module where a lot of stuff is there. One of the file I created as a NumPy class presentation. Rest of the things are available for you. You can able to utilize them. Okay, clear? So this file is made available for you. You can open it. You can see that. I hope everybody has a privilege to access this folder, right?
Let us check, sir.
Yeah, yeah. Okay. Okay. So I'm here demo about list data structure versus NumPy. So in what way list is going to be not useful? In what way it overcomes the drawback of a NumPy? Okay. Let's suppose I'll be taking a small example and the distance. Distance is the one particular list where I'm recording collection of values, like 10 kilometers, 15 kilometers, 20 kilometers, 20, 36 kilometers, 25 kilometers, like that. Okay. And time within which the distance is traveled, the time within which the distance is traveled. Probably I can be able to take like something called as 1.5, 2.5, 3.5, 4.5, 6.5, like that. So distance will be traveled by the car or bicycle and the time within which they traveled. So my concern is we want to perform certain operations. We want to perform. See, absolutely, you know that that list is a mutable data structure. So we can add the values, we can remove the values, we can update the values too. Okay. So now I wanted to perform. There is an operation is called. Let me execute this particular part. Then I'll be go with perform an operation to calculate speed, to calculate speed. So what is the formula? Basically, the speed is equal to distance. Already the distance we have, there is a list, distance divided by time, so that I can able to see the speed. Okay, I can able to see the speed. Now, as per your knowledge, whatever the formula you are applying it, here, this has to be take one value from the distance, one value from the time, one value from the distance, one value from the time. So this has to be applied, all the elements from each element from each particular list. Is this really happens or not is the important point. Let me execute to see the output now. What is an output given to you? It gives you an error. What is an error? This kind of operations cannot be performed. Unsupported operation. List cannot be able to perform it. Unsupported error. So the drawback here you're supposed to understand here is that, note, we cannot perform arithmetic operations directly from list to list elements. List to list elements. Clear? Because it will be treated as individual values. But whereas if you go to now Numpy basically supports multi-dimensional arrays. Multi-dimensional arrays over which you can apply mathematical operations. Okay. Now let the same operation we can able to perform through the Numpy. Let the same operation we can able to perform through Numpy. So whenever we deal with Numpy, firstly we have to import Numpy as NP. It's an alias name. Already we know that there is an alias name can be created. Okay. Yes or no? Now above one we have created through the list, these two lists. But now what I'll do, I will be create a I'll be create a Numpy from the list, because convert list to Numpy array. How exactly we can able to convert them? Already distance and time is here. Now Numpy distance is equal to Numpy NP there is a built-in function called as an array. You see, there is a built-in function called as an array for which I would be able to give the distance. Means list I am giving as an input so that Numpy array will be getting created. Okay. The next line is that Numpy time is equal to NP is the Numpy followed by an array of if we give the time. So if we give the time as a list to the parameter for the array, it converts as Numpy array and Numpy distance as well as time. After creation of that, you supposed to be performed. There is an operation now. Speed is equal to, isn't it? So Numpy distance divided by numpy time. Isn't it? Now it will be show you just simply if you able to let execute complete it. Now take another cell and then you just print that speed. You see the output. I hope you are seeing my screen. 1, 2,
Yes, sir.
like, yeah, 1, 2, 3, 4, 5. But whereas in the list, the same operation if you have done through the list, simply it has given an error because element by element cannot be taken because the list has the drawback. This is not supportable operation. Arithmetic operations directly we cannot perform on the list to list. But whereas the same list, if you convert into the NumPy, it is allowing because it supports the multi-dimensional arrays over the mathematical operations it will be applied. Which means what internally what is happening here? Isn't it? So if you want, you can able to print even distance and time also. Print np underscore distance. And absolutely we can able to print time colon this, and here also distance can also be seen. Here also we can able to see np underscore time. So if you look at the list, you don't perform this particular operation. Let's take another cell, and I'm printing normal what is called distance using list. Now here simply I could able to display the list distance and print. I could able to print time using list. See, I wanted to show you the difference. If the list will be created, how it is look like. If the list will be converted as a numpy, how it is look like. Let me execute this. You see the output. The output will be exactly like a list. Square brackets will be visible to you. But it is not showing you any kind of indexes here. It is a 0th index. It is a first index. It is a second index. It is a third index. It is a fourth index. Similarly. But if the same list I have converted into NumPy arrays, you see the output. Now what I'm doing here, I will be displayed to you. Now let me execute. I think let me take cut. Let me, yeah. You see, previously, if you look at in the list, there will be comma A will be there. For every element, there is a comma is separated, which means that there will be indexing maintained. But whereas if the same list will be converted as an array, it combinedly entire the thing will be as a single dimensional array. You see the problem? Here, there is no commas. 10, 15, 20, 36, 25 will be converted as an array by the NumPy, and absolutely it will be considered as a single entity, which is a single entity like an array. It is the one row, 5 columns, 1 into 5 matrix. 1 into 5 matrix. Is it clear?
Yes, sir.
Yes, absolutely. So some properties of the NumPy will be completely different from the list data structure, but they will be look like the same. Please be sure about They look like same, but their properties are different. Let us see now. I hope you understand how greater efficiency than the list data structure to the NumPy. Let us see now the properties of the n-dimensional array. Properties of n-dimensional array, because the NumPy will be basically supports the ND array. ND array is nothing but it follows the n-dimensional array concept. So what are the properties of n-dimensional array? Basically, it will be having a collection of values homogeneously, and it has a multidimensional values. It supports mathematical functions. It supports mathematical functions, and it allows. See, NumPy is obviously it is mutable. NumPy is mutable data structure or data collection, and absolutely it is very fast and efficient in terms of time and a space complexity. So if you look at the like a space and time complexity, just hold on. Just wanted to show you one example how time and be completely different from the what is called CUML. Mhm. So that is an example. I'll just let me show you. Yeah. So I have drag and dropped into our folder that I'm just opening the file. See, I'm just trying to demonstrate that how time and space complexity is greater NumPy than the list. So what I'm doing here, uh, let me yeah. See, if you look at here, I'm just demonstrating to you. Space complexity. Demonstrating you as a space complexity. What I'm doing here is that I took the NumPy. I took there is a time related system. SYS is the system related time will be captured. See here I'm allocating 1000 element space using range function. See, I'm creating one list which is having 1000 elements, which will be stored in store. Yes. And what this line says, system.sys.get size of s means this method will be storing each element is going to be occupy how much bytes of memory. If you know one element bytes of memory, so that we can multiply with complete number of 1000 elements, right? This particular line will be tells you that one element occupied memory into 1000 elements of memory, so that the total size, which is 1000 elements, will be occupied size will be displayed to you. Okay. Now the same 1000 elements I am going to be create using NumPy. Same np.arrange 1000 elements are getting stored into D using NumPy array, not using list. There is a demonstration is list versus NumPy. How list is going to store the space to store the 1000 elements? How much is going to be stored if we allocate the memory by the NumPy? Clear? Now D is the NumPy array which is having 1000 elements now. If I give item size, which means that it returns each element how much memory is occupied if you allocate by the NumPy. And if you multiply it, it will be give you 1000 elements how much memory is occupied. Now we have a the result is going to be show you space allocated by list for holding 1000 elements and space allocated by numpy for 1000 elements. Clear? Both will be shown as output. You see the output now? Let me execute it now. Yeah. So please clearly observe here. Each size, if we allocate the memory through the list, will occupy 48 bytes. See, I'm not decision maker. This Python interpreter itself is allocating it. 48 bytes will be occupied for each element. Now, if you multiply 48 into 1000, 48 thousands of the bytes of the memory will be allocated by the list data structure, 48,000 bytes. Now, if he comes to numpy, if you allocate a memory for each element through the numpy collection, it occupies only 8 bytes for each element. So 48 bytes, it is 8 bytes. Almost, as per my knowledge, 90% of the memory have been reduced to allocate each element to be stored into the system. NumPy will occupy only, see, you might not know, you might know or not, I don't know. There are different processors we have now. If you look at, CPU, right? What is the full form of CPU?
Central processing unit.
So we are using CPU now. In our laptop, CPU is there. What about GPU? What is full form of GPU and who made it?
Some
CPU
graphics
is
side.
made by Intel.
Yeah.
CPU is made by Intel company, processor company. GPU is, what is the full form of GPU?
I think graphics processing unit.
Correct. Who made this particular processor?
But
NVIDIA. NVIDIA company
okay.
is there. Correct.
Mm.
And comes to TPU. What is full form of TPU? TensorFlow processing unit, which
Yeah.
is made by the Google.
Mhm.
So now, why all these processors? Because, if you look at the CPU, the way it organizes the storage is different. The GPU will be multimedia, graphically, images, videos are able to organize them very nicely such a way that the processor is able to be processed the multimedia related applications, like geographical applications, all this. TPU is made by the Google especially to do the big data analytics. TensorFlow processing. See, we have to bother about the storage, because if you don't know the internal way of storage measuring strategy, why we are moving this kind of a process, we never get to know. Clear? So please, now totally, if we allocate the memory for the 1000 elements using NumPy, it occupies only 8000 bytes of the memory. But whereas if you take list data structure, 48,000 bytes, how much difference it has? It is huge difference. So as a whole, if we process huge volume of a data, huge velocity of a data, huge variety of a data, memory is matters, time is matters. I hope you understand. I think need not to think much more things. Yeah, right. Let us go ahead
Yes.
now. We have understand the space related complexity. list versus NumPy. So list is suitable data structure when you are dealing with less elements. But if the number of elements, huge elements, like the population of the India will be 150 crores above, then if you wanted to manage the Aadhaar related server, I think dealing with a list is not appropriate data structure. We have to deal with the NumPy data structures. Clear? This is how we supposed to be differentiate. Okay. Yeah. Okay. Let's go ahead. Let me talk about time comparison between the NumPy as well as list data structure. So what I'm doing here, I'm taking NumPy and I'm taking time. And here this line indicates, this is how much? I think this is 1 lakh. No, it is 10 lakhs.
1 million.
Yeah. So now the point is here, I wanted to be allocate these many elements using list. What I'm doing here, I'm making two lists, list 1 and list 2. If we perform the multiplication between, isn't it, 10 lakhs elements into 10 lakhs elements. Okay. Now, if you look at what I'm doing here, these two lines will be allocation of this list 1 is holding 10 lakhs elements. List 2 is holding 10 lakhs elements. Similarly, I'm allocating a memory by NumPy arrays. Array 1 is holding 10 lakhs elements and array 2 is also holding 10 lakhs elements. Okay. What I'm doing here, I'm trying to capture the current time. Before going to start the multiplication, I'm capturing the time. Initial time I'm capturing. Afterwards, I will be start performing the multiplication. What exactly list 1, list 2? I'm performing each element to be taken from list 1 and list 2, performing the multiplication, and the resultant list is getting stored into this. Afterwards, if after completion of the execution, I would be taking initial time I have captured, right? And the current time. Current time means after completion of multiplication, I'll take the time. And before start the multiplication, I'll take a time. If you subtract, it will be give you how much time it takes to perform the multiplication between 10 lakhs into 10 lakhs elements allocated by the list data structure. How many seconds have been taken? That will be given an output to you. Okay. Next. Same operation I'm does with array 1 and array 2, which means NumPy array 1, array 2. 10 lakhs into 10 lakhs element multiplication is taking place. Before that, I'm taking time. Afterwards, I'm taking time. So absolutely, if you look at, it will be give you the time to execute 10 lakhs into 10 lakhs multiplication by NumPy array and 10 lakhs into 10 lakhs multiplication by list 2 lists. Now let's see how much time will be difference between them. Yeah. If you look at very carefully that if we perform the multiplication between 10 lakhs into 10 lakhs elements by the 2 list, 0.101 will be the time in terms of seconds. But whereas the same operation, if it does with the multiplication through NumPy arrays, 0.0004 nanoseconds, I think, as per my knowledge, 99% of the time will be get reduced by the NumPy data structures if we perform the same similar operations. Are you clear, guys?
Yes, sir.
I think the capabilities of list data structure, the capability of a NumPy data structure you have been understand now. I think I need not to talk much about it. Very clearly have seen. In terms of allocation of the space, in terms of the execution time, both differences, both metrics are very important. Based on these two matrices, when to go to the list data structure, when to go to the Numpy data structure, it's the right way to understand. Yes or no? Are you clear, everybody? Yeah.
Yes, sir.
Yes. Correct.
Yes, sir.
Correct. Yeah. Absolutely. Let us understand a little more about Numpy array. Okay. There is the next concept. I hope this is already. I think this file is available for you. Let me go to this file because we are classroom things I'm executing through this, right? So I'll be go with this. Okay. I'll be taking types of arrays. So we know already this particular concept. In mathematics, we have seen the arrays can be one-dimensional array, 1D array, 1D array. Okay. Next, 2D array. 2D indicates what? Dimension. Next is that 3D array and n-dimensional array. More than 3 dimensions are going to become under n-dimensional array. ND array. N-dimensional array. As for mathematical perspective, you know that, right? One-dimensional array means what? Basically, one row, different columns. So how do we represent it as actually numpy dot array, where if we specify 10 comma 11 comma 12 comma 13, this is what? One dimensional array where you have a x-axis, like you have a x-axis. This is what? X-axis. It has only x-axis. And the length of this particular list will be 4 because it has a 4 elements. Clear? I hope this is already you guys are aware because in mathematics we are learned.
Yes, sir.
The problem with the one-dimensional array, can you tell me one drawback? Why we go to the two-dimensional array rather than having a one-dimensional array? Because the Excel sheet is an example of the matrix. If we store in a one row, many elements will be go to the right hand side. We have to scroll right hand side. And if we take a specific, a specific room, there is a room. If I ask you query, how many number of elements or how many number of students you can able to make them sit in this particular room, if we allowed to be sit like this, 1, 2, 3, 4, 5. What about 6, 7, 8, 9? We cannot allocate, right? Because one row. The same similar, if we allocate through rows and columns, absolutely 6, 7, up to 10, and 11, up to 15. Because here, this is an x-axis, this is a y-axis. This is a two-dimensional array. So what is the reference here? 0th row, first row, second row. 0th column, first column, second column, third column, fourth column. If you wanted to retrieve a particular desired element, we will be take a reference of the row and reference of the column so that this element is going to be referred. So the drawback of the one-dimensional array is if there is a huge volume of data to be organized without a waste of the memory, which means the allocation of the space, then very nicely we can able to organize in a rows and column wise in two-dimensional array in a concise manner rather than going this particular one-dimensional array in a same in this row. And space cannot be optimally utilized. That's the reason we go with a two-dimensional array. This is called as a two-dimensional array. Two-dimensional array is also known as a matrix. You have to understand that it is a matrix. It is a matrix. We can call it as a two-dimensional array. We can call it as a matrix. We can call it as a two-dimensional vector too. Yes or no? Now, if you go with a three-dimensional, what will comes into three-dimensional? The same above data can be organized in two-dimensional array mathematically or maybe programmatically. np.array in Python, np.array, where I would be create as a two-dimensional array. Yes or no? So where I will be allocating 10, 20 and comma here 12, 30. Yeah, this is the way how exactly programmatically and mathematically this is the representation we use to allocate the memory in a fashion of the two-dimensional. In general way, if you write simply like this, we can able to write in matrix, in mathematics. 10, 11, 12, 13. It is the 0th row, it is the first row, it is the 0th column, it is the first column. This is called 2 into 2 matrix. This is an x-axis, this is the y-axis. The intersect point we can able to refer accordingly. Okay, let's come to, if we write the same three-dimensional array, basically the three-dimensional array is going to be specified in what way? Absolutely. This is what? X-axis. This is what? Y-axis. This is what? Z-axis. This is called three-dimensional array or three-dimensional vector. Already we know that the space will be represented with a two-dimensional array, XY coordinations. But if you have a Z-axis, it will be comes under completely, always it will be a shadow. We cannot see. Side view we can see, top view we can see, but back view we cannot see. That's called as 3D, we can say 3D. Yes or no? So absolutely we can able to specify such kind of thing in mathematics or maybe in case of the programmatic way, that to be allocate numpy dot array, where we can able to take a function and we can able to specify like this dimension, where 1, 2, 3, isn't it? Comma 4, 5, 6, comma 7, 8, 9. This is one dimension. So how many dimensions are there? There will be 3 axes will be there. Now this is the x-axis, we can say. This data will be shown in a x-axis. Now similarly, we can able to allocate same space such as something called as same 1, 2, 3. This is the one, and 4, 5, 6. This is the one, and 7, 8, 9. This is another axis. This is another axis. Similarly, same 1, 2, 3. 1, 2, 3. Sorry, 4, 5, 6. You can take 4, 5, 6, and 7, 8, 9. Yeah, that's all. This is how 3-dimensional array will be organized. This is called, you know what? So here, one more bracket is required. Okay, this is what the 3-dimensional array. Here, the length is going to be 3. Length is going to be the 3, isn't it? And absolutely, these 3 are the 3 axes, we can say. 3 axes. 3 axes. Clear? This is called 3 axes. So absolutely, I hope you understand that, in terms of x-axis, y-axis, and in terms of the mathematically and programmatically, you can able to see. Yes, sir. So if you look at the in 3-dimensional way, absolutely this can be represented in terms of, what? I'll be draw that, let us see. So absolutely, this is x-axis. X-axis. This is y-axis. Absolutely, this one is z-axis. The how many number of rows and columns will be get decided based on the absolutely like this it will be decided. Like this it will be decided. So absolutely you have to understand this is front view. This is front view. This is the top view. This is side view. So if you look at a z-axis, the side view elements can be seen and top can be seen. But back to the front view cannot be seen. It will be hidden. For that reason, in the data warehousing, if you wherever we maintain the data, we have to be drill down, drill up, slice down, slice up. These operations will be, see, if you have a n-dimensional, let's suppose if you have a n-dimensional, absolutely tell me globe is the n-dimensional array, I can say. If you can see at a one front view, some kind of a world map can be seen. If you want the entire the world map to be seen, we have to be rotate, we have to be drill down, we have to be drill up, we have to be slice down, and we have to slice up. The same similar way we have to do on the top of the n-dimensional array concept. At a time, we cannot visualize in front of you. Guys, I hope you understand what I'm talking about. Mathematically, conceptually, physically, mathematically, all the things I can say. See, if you wanted to become a data scientist without having a fundamental strong knowledge in mathematics, I'm not saying that, high level mathematics. These are all, school level mathematics, I can say. Yes or no?
Yes, sir.
Absolutely. Is that clear, everyone, about a one-dimensional, two-dimensional, or three-dimensional in terms of conceptual, in terms of physics, in terms of mathematics, in terms of programmatics? All this
Yes, sir.
required. So absolutely, in tomorrow's class, I'll be talking a little more about operations mathematically, matrix-related operations, algebraic functions. There will be a lot of things we can do with image processing, video processing. Everything will be done through the only Numpy array. Please make sure about it. We are not learning like school level mathematics here. So it is dealing with a huge volume and velocity and variety of data. It deals with only the Numpy, because computer can understand only zeros and ones. Because
Yes, sir.
even though, let me show you, I will upload one particular image to binary. Now, if you upload the image, how computer can store into computer? Do you know that? Let me show you. It will be stored in terms of matrix, in terms of
Matrix, yeah. One second.
in terms of, yes, I'll be taking this image and let me convert it. Okay, you see the output now? Are you seeing? Guys, are you seeing my screen?
Yes, sir.
Yes, yes.
This is the way how exactly the data will be stored in computer. It understands only zeros and ones. This is matrix. If you want to perform the lower triangle, you can able to do like this. This is upper triangle, this is lower triangle. Diagonal matrix. Many more things we can able to apply on the matrix, because this particular data will be considered as a matrix. Even our face also will be like a matrix. Your nose will be there here. This portion will be recognized first. If you wear the mask, then this portion will be recognized. 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 Like it will be perform a segmentation. Lot of operations can be considered only if you convert your face into image into matrix. Matrix will be there in the form of a binary values. Therefore, Numpy is very popular. So please don't talk like Sir is talking about fundamental mathematics. If you go down, lot of operations we can do with only the Numpy. So kindly focus properly. So rest of the things in tomorrow's class I'll be talking about. Any questions till now, guys? Everybody? Aruna, Kevin, Leela, Satish, and
No,
Basti,
sir.
and Razalakshmi.
No, sir, for me.
No,
Please don't
But
bunk the classes, quite commonly. I'm seeing in another batch, almost 10 people are there. Only Satish is attending. What about remaining people? I don't know. Please, if you bunk the class, it's your mistake. Probably it's a loss of knowledge to you. But whatever the material, whatever things I might be kept over here, I don't think so. You will be practiced by opening everything. If you have a time, you can able to the things, everything, and you try to be understand them. Then you can able to understand what exactly I have given here. It's 20 years of effort to be create all this. Time to time we have created to give you the best knowledge to you. But if you really utilize it, that's your survival capability. You will be able to enhance it. Okay. Thank you so much to everyone. I think rest of the things will see the next class. Right.
thank you so much, sir.
thank you.
Thank you.